Hello, y'all. Today we're going to go over the states of matter, or sometimes it's called phases of matter, and it's going from a solid, liquid, and a gas. Okay, so our objective today is you're going to be able to differentiate between a solid, a liquid, and a gas. Also, know the direction of energy, whether it has shape, volume, and a structure. You're going to be able to identify the state of matter by its characteristics. Okay, so let's start with a solid. Solids have a definite shape, they have a definite volume, it's tightly packed, it's non-compressible, it has a lot of, or very little energy, sorry, and it can vibrate in place. So for example, like an ice cube, you might have very little movement, but eventually it will move. Okay, so now a liquid. It has some movement. It will flow from one container to another. It has a definite volume, but it doesn't have a definite shape. Okay, the particles are spaced further apart. It can be moderately compressed up to a certain point, right? Think of a sponge. If you squeeze it too hard, is it going to continue to contain everything? It's going to spill out, correct? Okay, and it has moderate energy. Okay, gases, unlike liquids, have no definite volume, and it doesn't have a definite shape. Why? Because those particles are spaced very far apart. They're moving very quickly. It has a lot of high energy, okay? And it moves freely. So think of a balloon. You may put a certain volume of gas in there, but once you try to seal it, gas will very quickly leak out. So that's why you don't definitely have a volume unless it's completely sealed. Now, mostly here in chemistry, we're going to be dealing with solids, liquids, and gases. However, you also have plasma. It can be found in fluorescent light bulb, neon lights. It's like a gas, but the particles are electrically charged. Okay, now looking at this little graph, you can start off with solids. Solids have a definite shape, a definite volume. Now, if you have something like ice, which I'll show you in a minute, and you add energy, it will eventually become a liquid. Once you have a liquid, if you add even further energy, let's say I put a cup of water on a hot plate. You add energy and it becomes a gas, okay? So the states of matter change as you add more energy. Okay, so now when you are changing from state to state, let's say gas vapor, and it goes down into a liquid, that's called condensation. Think about when you take a soda out of the refrigerator and you leave it on the table. Eventually that table gets a little bit wet, right? All of a sudden you have water droplets outside. Now on the opposite side, if I take a cup of water and I put it on a hot plate or on the stove, it's going to eventually go from a liquid to a gas. That's called evaporation. Okay, that steam can also be very hot and very harmful. So you always make sure that you don't put your hand or anything on top of something that you're boiling, or even like a popcorn. When you microwave popcorn and you open it, it has steam. That steam is gas vapor, but if it's hot enough, it can burn you. Okay, so don't forget the effects. Even if it's in a different state of matter, it can still function correctly. Okay, now if you're going from a liquid to a solid, you're freezing that particular particle. Now, this is just a physical change. It is not a chemical change. A chemical change changes your actual chemical formula. Here, if I take water and put it in an ice cube tray and put it in the freezer, it'll freeze, but it's still H2O, so it's a physical property. You're just going from one phase change to the other. Now, if I take that solid ice and put it on the table and leave it in a cup, what's going to happen to that ice if I forget about it? It's going to melt, right? Melting goes from solid to liquid. Now, you can have something that can go from a solid straight to a gas. For example, Carbon dioxide is one of those. It will start as a solid, it will skip the liquid stage and go straight into a gas. That's called sublimation. Okay, from a solid straight to a gas. Now, if you have a gas and it goes straight to a solid, that's deposition. Okay, now these are your different phase changes. Let's go to a few examples. Okay, here you have some examples of a solid. Copper wire is a solid. It's not going to move. Okay, it has very compact particles. Now you have a cube of sugar, and that's a solid. However, if you dissolve it, if you add water or something like that, it will actually dissociate inside the water, and it'll dissolve in the water and become a mixture. Okay, in the beaker you have some ice. That's a solid. However, with time, what's going to happen to this solid? Eventually, it's going to take up that energy, and it's going to turn to a liquid. Okay, here are some examples of liquids, like a bottle of coffee, water, and ice that's already melting. Okay, if I add more heat, eventually all of it will become a liquid, correct? Okay, even if I add heat from my own hand, or if I put it on a hot plate, this is a liquid, and it will take the shape of your container. Liquids. Okay, now gases. If I take this beaker and I put it on top of the hot plate, which I'm not going to leave right now because it'll get extremely hot, it will eventually go from liquid to a gas, correct? Now, everything has its own temperature. So here I have this. It's in a different type of liquid. It's not water. And if I add a heat source, it actually boils at a different temperature. You see how it's starting to move up? It starts to boil at a different temperature, and now it's producing gas. Okay? That's a different phase change from liquid to gas. And now I need to let it go so it can start going down. Okay? This is not a chemical reaction. This is a physical state from liquid to gas. Okay? Okay, now every element has its own melting point, freezing point. The closer you go inside the periodic table, the higher the melting and boiling point is. Okay, so for example, iron and cobalt are going to need a higher boiling point than something like potassium. Okay, every element at room temperature also can be, most of them are going to be at a solid state. A few of them will be in a liquid state, and some of them will be in a gas state.